talk about the law of cosines. The law of cosines is a way to solve triangles when we don't have matching parts of a side and an angle. So yesterday with our law of sines, we needed to have both a matching side and angle, both parts of one letter. The law of cosines is what we do when we don't have that happen with our given information. If you felt really good about the law of sines yesterday, then good news for you. The second half of every problem is going to end with the law of sines. So you'll be set to go with that. If you did not feel good about the law of sines, the good news is you have an extra night to practice it before we prepare for our quiz on Friday. So either way, we're the law of sines today. The law of cosines is just how we will begin. The law of cosines comes in 3 different forms. They really all mean the same thing. These are bullet points, not negative symbols. You do not need to memorize it. So as I said with the law of sines, you don't have to memorize it. It will be printed on the quiz for you. But I said you'll probably kind of know the law of sines by the time you get to the end of your homework anyway, because it's pretty straightforward. The law of cosines is not as straightforward, and I would not be surprised if you don't know it by the time you get to the end of your homework, but that's okay, because it will be printed on the quiz for you. You do not need to memorize this. It comes in 3 different forms, but they're really all the same thing, and it's important that you understand that and can notice that, because on the quiz, I'm only going to print one form of it, and you have to know how we're allowed to shuffle it around. So the key idea is whatever little letter is on the left-hand side by itself, that's the angle that we're dealing with inside a cosine. So when little a is alone, we've got big A inside a cosine. When little b is alone, we've got big B inside a cosine, and also for C. Then the other stuff is the other little letters. So if little a is alone, little b and c are through the problem. If little b is alone, little a and c are through the problem, and so on. So you don't need to memorize the formula. It will be provided, but only one of those will be provided, and you have to recognize how we can shuffle it around to plug in what we need to plug in. So we're going to set up our problems like we did yesterday by making a chart or a list of what we know and what we need to know. So I know side A, I know side C, and I know angle B. So I have 2 angles, I can't subtract from 180. I don't know both parts of one letter, I can't do the law of sines. That means the law of cosines is necessary. The law of cosines should always be a last resort. So check for those other things first. If you have 2 angles, subtract from 180 to get the 3rd angle. If you have both parts of one letter, use your law of sines. It's easier than the law of cosines. So the law of cosines is our last resort when those other 2 things don't work. So it is necessary here. We're going to use the form of the law of cosines that will allow us to find little b, the side that we're missing. So that would be the one that has little b all alone. So on your sheet, it's the second one that's listed there. But when little b is alone, big B is inside a cosine, and the other letters are the other 2 little letters. We plug in on everything that we know. We were able to plug in for every single letter on that right-hand side. So on the right-hand side, there are no variables. We know everything over there. Everything on that right-hand side is a button we can press on the calculator. So we're going to do it. All in one big piece, just type in that whole right-hand side. And I get about 97.4. That seems like a strange answer when I look at the other numbers in the question, because it's so much bigger than the other 2 sides. And if 97 is the biggest side, what does that mean about angle B? That would be the biggest angle. A biggest angle of 38 can't happen, because if the other 2 angles are smaller than that, we're not adding up to 180. What's wrong?
That's the square.
That is equal to b squared. I really emphasize this because this is a really common mistake. So we need to make sure we understand that equation. That's not our final answer yet. That's b squared. We get all excited about like plugging stuff in the calculator and answer popping out, and then we assume that's our answer. This is not our answer yet. B squared equals 97.4, so we need to take the square root of that to find what b is. So I get about 9.9. Which now means that b is the smallest side and 38 is the smallest angle, and that makes a little bit more sense.
Now we can use the law of sine.
Now we can use the law of sine. So every one of our questions will end the same way that we learned to do stuff yesterday. So a law of cosines will just be our first step, and then we'll be able to finish out problems with our law of sines. So when we know both parts of one letter, we can go back to our law of sines. Setting up sine of angle over matching side. But this is important. Yesterday, in doing our law of sines, we never had an option of what angle to solve for. But here we have an option, and it actually does matter. When you are going to use the law of sines to solve for an angle, you must always go for the smallest remaining angle. The reason is, when we go to solve this out on our calculator, when we go to solve for an angle, what are we going to have to do? What do we have to do to get our answer when we're looking for an angle? The inverse sine. The calculator is 100. The calculator would give us an answer of 80. Kind of that flip side of it. So it has meaning, but it's not right. So we need to make sure that we're always going for the smallest remaining angle. So the biggest angle is the last thing we find, and we'll find it by subtraction. So if it's bigger than 90, we'll get the right answer. So which one do I want to go for here? I want to use side 12 to go for angle A. We learned yesterday then we can multiply both sides by 12, or you can do a full cross multiply and divide out if you're more comfortable with that. And then we plug this into the calculator. And I get about 0.75, but that is the sine of A. So we need to take the second sine on the calculator, or the inverse sine of that, to get our answer for angle A is about 48. When you have two angles, always subtract from 180 to find the last angle. Do not do more trig. For one, it's a lot more work, and we don't want to do more work if we don't have to. And for two, like I said, if we would go for a law of sines, and it's supposed to be obtuse, we will get a wrong answer. So just subtract out from 180, gives us 94, which means if we had gone for angle C first, we would have gotten a wrong answer. The calculator would have told us the answer was 86.
Wait, what?
The calculator will not give you an obtuse answer when you do an inverse sine. So if we had chosen to go for angle C before going for angle A, the calculator would have told us that the answer was 86 instead of 94, because it's programmed to not give anything over 90. Because the actual number, since it's a circle, we can keep on going around and hitting the same thing every time. And so it has to pick an answer to give us.
So we always want to do A first.
So you always want to do the smallest first.
Yeah.
Not alphabetically A, B, or C, but always the smallest remaining angle.
I'm confused about where, like, after the sign of A equals 75,
It's 0.75, and when we're solving for an angle, that's where on our calculator we have to do the second sine of that 0.75, the inverse sine of that 0.75. Other questions on this problem? Go ahead and try the next one, which is the same type of setup, same type of given information. Let's go ahead and look at this one. We begin by creating our list of what we know and what we need to know. So we do not have two angles. We can't subtract from 180. We do not have both parts of one letter, so we can't use our law of sines. We need to use our law of cosine. In one piece. If you try to type it in multiple pieces, you will likely make an order of operations mistake. So you want to type the whole line in one piece.
Okay, squares and everything.
Squares and everything. Type it in exactly as it looks, all in one piece. If you try to split it up, you will likely make an order of operations mistake. That gives me a 714, but that is a squared. So we need to take a square root of that, and I get about 26.7. At this point, going to matter, because it's only going to matter if it's possible that one of our angles is obtuse, because that's where the calculator will give us a wrong answer. And I can tell by looking at this question that I'm not going to have an obtuse answer for B or C. How can I tell that?
Because
the values of the sides are close together, and that means, like, you know, the remainder of 180 minus 81 is 99, and that split up like roughly evenly won't get anything close to 90.
Okay, so one way to kind of balance out the sides. It's not a guarantee, but one way is to kind of look at the sides being close together, so the angles are probably going to be close together. What'll guarantee it?
when you minus the first thing from 180, if it's less than 90, then it's obtuse, and then, right? No, never mind. No, that's false information right there.
All right.
It's because you already have an angle bigger than 90 degrees.
I don't have an angle bigger than 90 yet. My base angle is 81.
Oh, wait.
If I already have something bigger than 90, then I know I can't, because we can only have one obtuse angle, right? But I have, that's an acute, so there's still a possibility of an obtuse, but how do I know it's not going to happen? What's our quick double check?
Oh, the lengths are smaller.
This is our biggest angle. 26 is the biggest side, so this is our biggest angle. So if 81 is the biggest, we're not going to get anything bigger than 81. We're not going to get any obtuse. So I can tell it's not going to happen, but unless you want to go figure out how you'll be safe no matter what. So go for the smallest remaining, which is C. Multiply both sides in that law of sines by 19. Type that into the calculator and take an inverse sine. And that gives me about 45 for C. And subtract out leaves 54 for B. Questions? Okay, there are 4 different kinds of problems you can solve. types of problems, they tend to get a bit lengthier or trickier, and that's the case here. This is the lengthiest, trickiest type of problem with our law of sines and cosines, so just a heads up on that. So we don't have two angles, we can't subtract from 180, we don't have both parts of one letter, so we can't use law of sines, we need law of cosines. We always want to go for the smallest remaining angle, which is going to be which one? A is going to be the smallest angle. That means we want to use our law of cosines formula that has angle A in it, which means that it must have little a all over. So it's the first form that's listed on your worksheet. Plug in everything we know. This time, though, we do not know everything on the right-hand side of the equation, so we can't type it all in one piece. That capital A is a variable. We can't type that on the calculator because the calculator doesn't know what A is supposed to be. So that means we have to plug this in actually in a few pieces. The first thing we're going to calculate is the thing that's by itself. So that's 64. The next thing we're going to calculate is the rest of the squared stuff. 18 squared plus 13 squared. Which gives 493. And then we're going to calculate the multiplied stuff. 2 times 18 times 13, which gives 468.
Wait, should we do that subtraction?
No. So, I now want to do a little side note here because there's a super common student mistake that happens here. And I want to show you that you really know what you're supposed to do. It's just that when the numbers get messy and we start putting trig stuff into it, we kind of forget about our basic algebra rules. So, side note question. If I had something like 12 is equal to 8 minus 6x, what would I do first to solve that equation? I would subtract 8 from both sides. Early on in Algebra 1, we will often make a mistake of trying to put the 8 and the negative 6x together and saying that we have 2x over there. Early on in algebra, that tends to be a pretty common thing, trying to put together terms that are not like. But then we can learn we can't do that. If they're not like, if one has a variable and one doesn't have a variable, we can't put them together. So we can't subtract those, we have to subtract the 8 from both sides. Our equation in this question is exactly the same type of equation as that one. We have a number equals a number minus a number times x, except it's a cosine. Okay? It is exactly the same type of question, but when numbers get big and trig comes in there, students forget about basic algebra rules and always want to do the subtraction here, 493 minus 468. You cannot, and the good thing about this mistake is you will get an error message eventually, and hopefully when that error message pops up on your calculator, you will remember this lengthy lecture on what you have done wrong, and you'll say, ah yes, I need to go back a few steps and not combine that 493 and 468. So, just like we would want to subtract 8 from both sides, we want to subtract 493 from both sides.
Could we add 468 cosine of A to both sides?
You could add 468 cosine of A to both sides and subtract 64 from both sides, but that's 2 steps, and this is just 1 step, so it's faster to do it this way. But if it makes more sense to you the other way, you could definitely do it that way. Second caution of this problem is don't lose negatives. It's really easy to do that, especially this negative in front of that 468 often gets lost. So be careful you don't lose negatives. Then we're going to divide out that negative 468 on both sides. And that gives me 0.916 repeating is the cosine of A. And so how do I find what A is? The inverse cosine, or on the calculator, the second cosine of that answer gives us our first answer, about 23.5 or 24. questions on that process? That's the new part of this question. From here on out, everything will be review of stuff that we learned yesterday. And this first part of the problem. Okay, from here on out, both parts of one letter, so I can set up a law of signs. Sine of 24 over 8, and it does matter sometimes, so we're always going to be careful. What do I want to go for next?
C.
C, I want to go for the next smallest. Multiply both sides by 13. Type that in the calculator. And then take an inverse sine to get about 41. And always when you have two angles, subtract from 180 for the leftovers. Trig is more difficult and can give you a wrong answer, which it would in this case, because angle B is obtuse. So, once again, a few warnings. First major warning, do not Today, we're mixing the two. So sometimes we're doing cosines, sometimes we're doing sine. Make sure you are pressing the appropriate button at the appropriate time. Okay, so be careful that you keep those straight. What is sine and what is cosine? Go ahead and try the next example question with the side, side, side case. So I subtract 244 from both sides. It gives me negative 180. Then divide to get 0.75 equals cosine of A. Take an inverse cosine of that 3/4 to get 41.4, or we'll round it off to just 41. We then have two parts of one letter, so we can return to doing the law of sines like we did in the last lesson. Still going for the smallest remaining angle, so going for C. Multiply both sides by 10. Plug it in the calculator and do an inverse sine. Again, be careful when you're pressing sine and when you're pressing cosine. And I get about 55. Always subtract from 180 for your final answer, which gives 84 this time. And you can still do that quick double check that we talked about yesterday to make sure smallest angles are matching smallest sides, biggest are matching biggest, to confirm that your answers are probably right. Doesn't guarantee it, but it means probably. Questions? Your homework is from 13-6.